Okay, welcome back, and this is video 2. So you can see here that the step forward I've taken from video 1 is I've just copied our Desmos graph across. And if you had a look at video 1, and I hope you did, you'll notice that there are two solutions, or you recall that there were two solutions to our equation. One of them was there, and one of them was there. We were trying to work out where the function y equals 2 cos x minus 1 is equal to the function y equals 0. Which actually resulted in giving us the equation 2 cos x minus 1 equals 0. And we had a restricted domain here of 0 to 2 pi. So that means we're only looking for solutions between 0 and 2 pi. And so while there are an infinite number of solutions, we only want the solutions in this range. And so you can see why the two that I've circled are the two solutions, the 2 point of intersections there. Now in the start of the first video, we did the obvious rearrangement to get down to our first solution. So it was just a case of add the 1, divide by 2, take the cos inverse, put it in your calculator, or remember the exact values we already know. There's our first solution. Now you've done some work on symmetry of angles. So once you get to the first solution, the next step is going to be to try and find the second solution. And to find a second solution, the best way to do that realistically is the unit circle. The graph is quite good actually, and I've been known to use the graph in the past, and it can really help you, but it can be a bit more laborious drawing a graph and finding all the solutions from that, and less easy to get accurate. The unit circle, and not even a circle really, just lines on a cross, make it really easy to find it. The first thing I do is I draw the cast diagram, C-A-S-T, and I recognize that I'm dealing with a cos function there, and I'm dealing with cos x equals a number here that is positive. So I know that cos x equals a positive value. So where is cos positive? In the first and the fourth quadrant. That tells me I'm looking for solutions in the first and in the fourth quadrant. Now I already know my first quadrant solution because I got that in video 1. So I'll just draw a little line here. That first quadrant solution was pi on 3. So that's all good and well. Now I know that I've also got some equivalent values in all 4 quadrants just using this cross method, where these are all pi on 3. But I don't want to sound harsh to quadrant 2 and 3, but we really don't care about them in this question because we are looking for when cos x equals a half. So we're just looking for the solutions for where cos x is a positive. And that's just in the first and the fourth quadrant. So whereas this is pi on 3, that's our first solution. Our second solution is, there's 2 pi. This value is 2 pi minus pi on 3. Remember, 2 pi is also 0. Right? That's the full rotation around is 2 pi on 0. So we could also just write minus pi on 3, but that would give us the solution here, minus pi on 3, and that's outside of our domain. So the solution we want is over here. That's our second solution, and it's 2 pi minus pi on 3. So 2 pi minus pi on 3 is equal to 5 pi on 3, because 2 pi is 6 pi on 3, and 6 pi minus pi is 5 pi. Definitely go back and practice your fractions and add some pi's into the fractions, and you'll find you get really good and quick at this. So 5 pi on 3 is my second solution. I've got a solution of pi on 3 and a second solution of 5 pi on 3. This solution is often called the reference solution. And the way I would set my question up now is by setting up two sets of solutions. X equals pi on 3 and x is equal to 5 pi on 3. And this will become really important a little bit later on. In video 3, I'm going to give you a second example where we now have to find further solutions. But for now, we're actually finished. Within this given domain, we've got both of our solutions. Our first one is there and our second one is here. So we're done. Pi on 3 and 5 pi on 3 worked within this domain. And that's the question over. So just as a reminder and a quick run through the steps. In class, I'll give you the steps as a list. But the first thing you need to do with a trigonometric equation is to rearrange so that you get the cos x equals a number or the sin x equals a number, etc. Then solve to get the first solution using exact values or your calculator. Then find the second solution using your unit circle, which we've done. The fourth step, which we didn't have to do, is finding subsequent solutions in beyond the one period by adding or subtracting full rotation. So that's 2 pi or 360, depending on the units you're using. Then you need to find all the solutions within the domain you've been given. But that's the end of this example, so I'm going to stop video 2 now, and we'll do a more complex example in video 3, which will involve a couple of different aspects. So all the best.